Okay, pre-cal students, welcome to the homework help video, page 788. The following numbers, let's go ahead and get started with number 1. On number 1, we will be solving this triangle, so here we go. Notice right away that we have always learned students to check your scenarios. In this scenario, we have an angle, side scenario. Okay, remember the one we're worried about is a side angle scenario. Those are the ones that can have no answer, one answer, or two answers, okay? But we have an angle side scenario or case, so we're good. So here we go. We're looking for a pair so that we can use the law of sines. Actually, first of all, let's go ahead and solve for angle C. So angle C equals, let's see, 105 degrees, correct? Because we're going to add this plus this and subtract from 180 and get 105, okay? All right, next we're looking for a pair, and we have a pair right here. We have A is 20 over the sine of A, which would be the sine of 30, okay? And now with that in mind, we can either solve for B first, side B. We already found 30 right here. We can solve for side B, or we can solve for side C. It really doesn't matter which one we do first. Well, I'm going to go ahead and solve for side B. So I have B over the sine of 45 degrees. Okay, so we cross cancel. All right, if we cross cancel, we have 20 sine of 45, and of course B sine of 30. And I'm skipping some steps here, students, but you guys can handle that. Then we divide both sides by the sine of 30. We end up with this right here: 20 times the sine of 45 divided by the sine of 30. Okay. Now remember, type in 20 sine of 45, hit enter before you hit divide by sine of 30. And if you type it in correctly, you should come up with 28.28. Okay, so there is side B, 28.28. All right, let's continue on. And now let's solve for side C. Now when you solve for side C, I recommend that you start off with the same ratio. The original pair that you had, 20 over sine of 30, A and A, and now we're going to solve for side C. So side C over the sine of 105. Well, if we cross multiply and then divide, we'll end up with this right here. C equals 20 sine 105 divided by sine of 30. Okay? And if you type that into your calculator correctly, 20 times sine of 105, enter, divided by sine of 30, enter, you should get 38.64. Okay, so there we go. And as you can tell in your homework assignment, we're not going to do a lot of these. I felt like they're very redundant, and it's the same thing over and over and over, okay? So there's really no need to do these over and over, all right? Okay, let's try number 5. Number 5. And then I think did I say number 5? Actually, we're not going to do number 5. We're going to go on and do number 19 instead. Okay, number 19. And actually number 17. Okay, we're going to go ahead and do number 17. Okay, students, here we go. Number 17. Now, first thing you want to do here, number 17, students, is go ahead and draw a triangle. It doesn't have to be drawn to scale. Just draw a regular, good old-fashioned oblique triangle like that, and then we'll just label our vertices A, B, and C. Now, A is 55 degrees. Okay, B is 42 degrees. C we don't know. Side C though over here is 3/4. Okay, so what we have in this scenario is, students, look carefully. We have angle, side, angle, side, angle. And always remember to check that, okay? Because once again, if we have a side, angle, then that's going to be not a good situation. One we're going to require a little more work, okay? All right, here we go. Let's go ahead and quickly find our third angle here. And angle C would be 83 degrees, okay? And now I have a pair. I have a side here and an angle here. So my pair is going to be 3/4 over the sine of 83 degrees. Now next, it really doesn't matter if we solve for side B or side A. I went ahead and decided to solve for side B. So I'm going to put a B here and then sine of 42. Now if we cross multiply and then divide, we're going to end up with this. B equals 3/4 times the sine of 42 divided by the sine of 83. Okay? And if we type that in correctly, we will get out a kind of a weird length, but it is accurate. It's 0.51. Okay? So the length of B is 0.51. There we go. Now, let's go ahead and use our original ratio here from the triangle. And now we're going to solve for side A. So side A over the sine of 55 degrees. All right, we're going to cross multiply and then divide, and we'll have A equals 3/4 sine of 55 degrees divided by sine of 83. Okay, and if you type 3/4 sine 55, enter, divided by sine of 83, enter into your calculator, you will get 0.62. Okay, so side A will be 0.62, and there we have solved the entire triangle. Okay, now let's go ahead and jump to numbers 19, 21, and 25. These are the ones, all three of these students are angle side side or side side angle, and so we're going to have to be really careful on these and make sure that we check for two solutions. Okay, so here we go. Number 19. Let's go ahead and draw our triangle here. There we go. And we'll label it A, B, C, and here we go. Angle A is 58 degrees. Side A is 11.4, and side B is 12.8. Notice we have side, side, and then an angle, okay? If this angle right here was over here, then we'd have side, angle, side. And that's not what we have, okay? So we have side, side, angle. So we are going to have to check for two solutions as we work our way through this, okay? All right, here we go. Let's go ahead and look for a pair. And I do have a pair right here. I have sine of 11.4 over sine of 58. Okay? Now, we really can't do anything with angle C because we don't know angle C and we don't know side C. Okay? So that's really not an option. However, we can find angle B because we do know side B, which is 12.8. Now, if we cross multiply and then divide, we're going to be left with this right here. Sine of B equals 12.8 sine of 58 divided by 11.4. Okay? Let me check my work here, students, real quick, make sure I have that correct. And actually, let's see, is that a 58 or a 50? Hold on one second here. Let's see here. Okay, it is sine of 58, so we continue on. Now, if you type this whole thing here, students, into your calculator, you will get out a decimal. I don't know what that decimal is, but I know after you get that decimal, if you take inverse sine, you will get angle B equals, and let me look at my notes here, 72 degrees, okay? 72 degrees. So there's angle B. Now remember what I taught you in your notes. This is where you stop, okay? This is where you stop and you check to see if there's another triangle that exists, okay? And there could be. Let's quickly find out, okay? So we're going to draw another triangle over here. And we're going to label it ABC like the other triangle. Okay, and they gave us 58 degrees was the original, and 11.4 was the original, and 12.8, okay? Now, remember what to do when you find your first angle, like we did right here, in a side-side angle case. You take the angle that you just found, and you always subtract it from 180. So 180 minus 72 is going to give you 108 degrees. 108. So we put that up here for angle B, and then we see, is it a possibility? Now, if it is, then unfortunately we have two triangles to solve for, okay? So let's see if it is. 58 plus 108 is 166 degrees, and it is possible if angle C does exist, angle C would be 14. So we do have two triangles. So we will come back to this triangle later and solve this triangle here later, okay? Now let's come back over here. We found angle B was 72, so very quickly we can find angle C, and angle C is 50 degrees, okay, by adding these two together, subtracting from 180, and now we just have one side left to solve for, and that's side C, okay? So here we go. Side C over the sine of 50. So if I cross multiply and then divide, I'm left with C equals 11.4 sine of 50 divided by sine of 58. And if I type that in correctly, I'm going to get 10.3, okay? So C equals 10.3. So I am totally done with this top triangle here to the right, okay? There we go. Now let's come over here to the other side, and we're going to use the same ratio, I believe. Yep, exact same ratio. Right over here. And let's see what we have to find still yet, okay? 12.8. Now, I've got to be careful. I'm not sure where that came from. I should not have brought that over. Oh, yeah, that's exactly right. Yeah. So we have two sides here. We found both angles. We just have one side to find very quickly, and that's side C, and we're done. So side C over the sine of 14 degrees. Cross multiply and divide, and you're left with 11.4 sine 14 divided by sine of 58, okay? And if you type that into your calculator carefully, you will get 3.25. 3.25. And again, my triangles are not drawn to scale, and that's totally fine, not a big deal. And there we go. So sometimes you'll have no solution, sometimes you'll have one solution, and sometimes you will have two solutions. Okay, students, moving on to number 21. Number 21. Alright, here we go. Let's draw our triangle quickly here. And let's go ahead and label our triangle A, B, C. Angle A is 76. Side B is 20. Side A is 18. Okay? So we do have a side angle scenario. So we have to check for two solutions. Here's our pair right here we're going to use. Okay? So we have 18 over sine of 76 equals, and let's see, we know nothing about angle C, we know nothing about side C, so let's look at angle B. We know side B is 20, so 20 over the sine of B, and if I cross multiply and divide, I will have the sine of B equals 20 times the sine of 76 divided by 18. Now, I'm not sure what that decimal is, but you type into your calculator 20 times the sine of 76 divided by 18, enter, then take second sine of B, and you will get for that no solution. Okay, it doesn't work. So immediately we know there's no solution. Okay, once again, if you type this in, you will get out a decimal, and then you type in second sine of this decimal right here, and you will get no solution, doesn't work, error, whatever your calculator says. Okay, so the answer is no solution. In other words, no triangle exists, students. No triangle exists that has these measurements right here, these three measurements. It is impossible. Okay, cannot be done. Okay, number 25. All right, here we go. Let's go ahead and draw our triangle very quickly here, and then we will label everything. A, B, C. A is 22 degrees. Side A is 5/7, and side B is 5/7. Now, here we go. First of all, I realize I have angle side, so I better be careful and check for two answers, which I will do. My pair is 5/7 over sine of 22 equals 5/7 over the sine of b. Now let's go ahead and cross multiply and divide, and we'll come up with this right here, sine of b. Actually, let's just stop right now. Look at this, students. I mean, if I had this, if I had 1/2 equals blank over 2, well, if I have a 2 here and a 2 here and a 1 here, then x has to be 1. They're equal. Well, look at this, guys. We have 5/7 over 5/7. Sine of 22, sine of, we know right away this is going to be 22. Now you can work it out and you'll see you will get 22 degrees for b, okay? So there's really no need to go any further. It's pretty simple. So the sine of b is 22. Now, we need to see if we have another triangle. Okay, that might happen. So here we go. Let's draw another triangle over here. Let's quickly label it A, B, C, 22, 5/7, 5/7. And what angle did I just find? B, and B was 22. So, we're going to take 180 minus 22, and that will give us 158. Okay? So we come over here and put 158. Now, if you add 158 plus 22, you get 180. So that means this angle over here would have to be 0 degrees. Which, of course, is impossible, students. So, this triangle here does not exist, okay? So we just have one triangle to worry about. And so real quick here, angle C should be pretty easy to find. 22 plus 22 is 44. 180 minus 44 is 136. Alright, and now we can quickly find side C. We can say 5/7 over sine of A equals side C over the sine of 136. Cross multiply and divide, and we will get 5/7 sine 136 over the sine of A. Okay, and let me look at my notes here real quick and see what we have. And of course, students, this should be a 22. Sorry about that, 22. So this should be a 22. If you type this in your calculator correctly, you will get for C 1.32. Okay, so there we go. And that triangle is solved. Okay. Now, number 27. This is an area problem. Okay. And real quick, if you'll label this triangle, just watch A, B, C, and then put 120 for C, and for side A put 4, and for side B put 6. Listen, students, anytime you have a triangle in which you have side, angle, side, like that, you can find the area just by taking 1/2 times one of the sides times the other side times the included angle, well, the sine of the included angle, okay? So 1/2 times 4 times 6 times the sine of 120, you will get 10.4. Now, if you're wondering where that formula came from, I can probably show you very, very quickly, I believe, hopefully. Actually, I had another video I was going to do for you guys to go over that. I will not take time now to do it. I will say this. You drop down a line here and you call it H, and you start off with the area of a triangle as 1/2 base times height, like this, and then you substitute in for B. You can use the cosine, I believe, something like that. I could do it. I'm not going to take time now and do it, but it's really a simple proof where this formula comes from, and also the law of sines is also a really easy proof. So maybe we'll get into that later. Okay. All right. Moving on. First word problem, number 41. Okay, so pretty tough problems. Here we go. Please pay really close attention. I will try to help you. These are really difficult to do. So let's see how we do here. Let me get my notes out here real quick. Hold on one second. And here we go. Okay, now they tell us, I mean, I can read all the information here, but they've given us a pretty good picture. So I'm going to I'm going to jump right down to the picture here and look at what they want us to find. They want us to find theta, the angle of elevation. Okay, now here's theta right here. Don't miss that. There's theta. Now 42 degrees, listen to me students, 42 degrees is not this angle right here. It is the whole angle. Okay, so understand that. So here's 42 degrees, the whole angle, here's theta. They want us to find theta, okay? Now, here's what I'm thinking. I'm looking at this oblique triangle right here. Okay, look at this. See that? Now here's what I'm thinking. They want us to find theta, this little angle right down here, theta. So I know the whole angle, guys, is 42 degrees, right? The whole angle is 42. If I can find this little angle right here, and then take the whole angle 42 minus this angle right here, then I'll have theta. Think about that. The whole angle is 42, okay? If I can find this little angle here, then I can subtract from 42, and I'll have this little angle here. This is what I'm looking for right here. It says to find theta, okay? So with that in mind, here's what I'm going to do. I'm going to copy this triangle over here off to the side. So here we go. This triangle right here comes down like this, then comes up, and then comes up. That's good enough, okay? Now, it looks like this length right here is 10. I'll put a 10 here. This angle right here is 48 degrees right here. And then this side here is 17. So do I know 3 sides of this oblique triangle? Yes, I do. Or excuse me, do I know 3 parts? Yes, I do. So I can find this little angle right here very easily, guys. Look, 48 goes with 17, okay? So I have 17 over the sine of 48 equals 10, of course, goes this angle over here, and we'll call this x, I guess, the sine of x, okay? So if I cross multiply and divide, I'm left with sine of x equals 10 sine of 48 divided by 17. Alright, now let me look at my notes here real quick. If you type that into your calculator and get a decimal, and then take second sine, you will get 26 degrees for angle B. So this angle here is 26. Now let's erase all of this, okay? So this angle right here, this little angle right here is 26, okay? And the whole angle is 42. So if I take 42 minus 26 and get 16 degrees, then that has to be that little angle down here, 16 degrees, okay? And that is the answer, okay? 16 degrees. All right, number 43. Again, I'm all for drawing pictures. I think it's very important that you learn how to do that, but they've already given us a very nice drawing here, so I'm going to just kind of glance through this and come down to the end. Find the distance from the gazebo to the dock, okay? So here's the dock. Here's the gazebo. I'm trying to find this distance right here, okay? Now, first of all, here's what I'm thinking. If I can find, watch this carefully, if I can find this angle right here, okay, that will help me find this angle here. Now, why would I want to do that? Well, I'm glad you asked. Watch this. Let me go over that again. If I can find this angle here, then I can find this angle here pretty easily, okay? Now, why would I want to do that? Well, look, guys. Look, here's 100. This is the only length I know. So 100, using law of sines, 100 goes with this angle right here. And then don't forget, I want to find this side right here. So this side right here goes with this angle over here. So I really need to find this angle here so I have a pair to work with, okay? A pair from my law of sines. Now watch this carefully. Let's start really dissecting this thing, okay? Watch carefully. First of all, you need to remember this from geometry, okay? Please look at this. We have parallel lines. Look at that. There we go. They're vertical lines. I know that because remember, whenever you draw bearings like South 41 West, south, 74 east, you have to draw vertical lines. So vertical lines are parallel. Now look at this transversal right here. Look at that transversal. Look at that, okay? Now we know this whole angle from here to here is, what did they tell us what that is? 74? Yes. This whole angle right here is 74. Got it? 74 degrees. Now watch this. I'm going to pull this out of the way. Watch. Think back to geometry class, guys. Remember, whenever you have two parallel lines, now watch this. Whenever you have two parallel lines cut by transversal, this angle here with one dot and this angle here with one dot, they're called consecutive interior angles. And consecutive interior angles are not congruent, they're supplementary. So this angle right here is going to be 106 degrees. Got it? Because 74 plus 106 is 180. Now, having said that, let's turn this back around again to where it was, okay? And pull this back up here. Now, so now, hopefully I can get this right here. Now, this whole angle right here, I'm going to erase it in a second. This whole angle right here is 106 degrees, okay? The whole angle. So, let me slide this over a little bit. Be patient with your teacher here. So the whole angle is 106. Now it looks like to me this angle right here is 41, okay? So if this angle is 41, the whole angle is 106, then 106 minus 41 is going to be 65 degrees, okay? So this angle here inside my triangle is 65 degrees. So now I'm getting somewhere. Okay, now let's come up here and find the angle inside this triangle here. Okay, watch this. Now, if this whole angle is 74 and this much is 28, then the angle up top has to be, let's see, would that be 74 minus 28 would be 46. So this angle right here inside your triangle right here has to be 46 degrees. Okay? Now, if I know the top angle is 46, and I know this angle over here is 65, then this angle right here has to be 69. Has to be. So there, I have a triangle now in which I can very easily use the law of sines, okay? Let's get rid of all of this extra baggage here we don't need. There we go. There we go. And there we go. And there's my triangle. Look at that. So, do I have a pair? Yes, I do. 100 goes with 69. So 100 over sine of 69 equals, don't forget this is the side you're trying to solve for, we'll call it x, goes with 46 degrees, so x over the sine of 46 degrees, okay? And now let's cross multiply and divide, you'll get x equals 100 sine of 46 over the sine of 69, okay? And if you type that in correctly, you will get 77.054 x, this length right here. Okay? All right, I hope that's made sense. Let's move on to number 45. Number 45. Now, students, in my opinion, number 45 had a lot worse bark than a bite. Okay, it's really not that hard of a problem. Let's go ahead and get the drawing set up here. A pilot has just started on the glide path for landing in an airport where the length of the runway is 900 feet. The angles of depression are these two angles here. Okay, let's stop right now. Let's get a picture of this. Okay, here we go. Here's my runway. My runway goes from here to here. Okay, and remember, we do not care. Not only do I not care if my drawing is drawn to scale, I actually hope that it's not, because it'll give me big enough angles, space to work with my angles, okay? I really don't want to draw an angle at 17 degrees. That's a really small angle, okay? So the length of the runway is 9,000 feet. So there's the runway. Here's the plane up here, okay? Now, if you wanted to, you could put the plane over here. That's fine. I'm just putting the plane over here. Now, slide this up a little bit. Okay, so here we go. Now, please watch this carefully, students. It says we have two angles of depression. Never draw an angle of depression or an angle of elevation until you first draw the horizontal line. You must have a horizontal line always before you can draw an angle of depression or elevation. So there we go. Now, the angles of depression always go from the horizontal line to the line that we're referring to. So one angle goes from here to here. One angle goes from here to here. Now it's obvious which one's bigger, okay? 18.8. So the whole angle's 18.8. The little angle's 17.5. So watch what I do. Here's what I do. I put 17.5 in here. And if the whole angle is 18.8, then this little angle right here must be 1.3. Now I know it doesn't look like 1.3, but I really don't want to try to draw an angle that's 1.3, okay? Now, let's see what else I can figure out here, okay? Find the air distance the plane must travel until touching down. So here's the plane. It is going to touch down here at the edge of the runway. So the air distance is this line from here to here. Now, right away I'm thinking, look, I've got a oblique triangle right here. Right here, look at this. And I have a pair already, look. 9,000 goes with 1.3 degrees. Okay? So if I want to find x here, all I have to do is find this angle right here. And I really think I can do that. So here we go. Watch this. Look right here, guys. Hopefully, the runway is horizontal, okay? I hope it's not unlevel, okay? So here's the runway, okay? Now the runway is going to be parallel to this line up here. So I have two parallel lines. Here we go again. Look, cut by a transversal. Two parallel lines cut by a transversal. So from here, these two, remember this guy's from geometry. Boom, 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 okay? Now, this angle here and this angle here are called alternate interior angles. And when two lines are parallel, cut by a transversal, those two angles are always what? They're always congruent, okay? So, if this is 17.5 here, then this is 17.5 here. So now I'm good to go. Call this side X right here, okay? Let's erase all of the distractions here. We don't need all this, for now anyways. And there's my triangle. So here we go. My pair would be 9,000 over the sine of 1.3 equals x over the sine of 17.5. Now, go ahead and cross multiply and divide. So x equals 9,000 sine of 17.5 divided by sine of 1.3, okay? Now, if you type that whole thing into your calculator, you will get this. You will get x equals 119,289 feet, which is fine. The back of the book had their answer in miles, so if you want to leave your answer in feet, that's fine. You're more than welcome to leave your answer your answer in feet. Or you could also convert to miles by taking 119,289, dividing it by how many feet are in a mile, 5,280, and you will get 22.6 miles. Either way is fine. doesn't matter, okay? So moving on, here we go. I'm going to go ahead and put the feet right here, 119,289. Now let's continue on. Let's see what else they want us to do. Number C, or letter C, they want us to find the distance, find the ground distance the plane must travel until touching down. So here's the plane, okay? Here's where it's going to touch down. The air distance was from here to here. The ground distance is the plane is here and it ends up here. So the ground distance is the distance it travels from here over to here. That's the ground distance. Well, that's easy. Call that y. And look, we have a right triangle. We have a right triangle. That's so easy. Okay, now if this angle here is 17.5, got it? And this angle here is 1.3. Add those two together and subtract from 180, and you'll get 161.2. Well, this is a straight line right here, so this angle here and this angle here have to add up to 180. So this angle right here inside the triangle will be 18.8. And I've got a right triangle. So I've got the length of the hypotenuse right here. I've got an angle here. I can easily find y. Based on this angle here, I have adjacent and hypotenuse. Based on this angle here, I have adjacent and hypotenuse. Let me go ahead and do this real quick, and I'll put it back up here in a second. But if you'll look, students, what I have is a good old-fashioned right triangle. There it is, okay? Okay, so I have adjacent and hypotenuse. All right, so here we go. Let's see what we have here. We have cosine, because cosine is adjacent over hypotenuse. Cosine of 18.8 equals adjacent over hypotenuse. Okay, multiply both sides by 119,289 cosine of 18, and you will get for y this right here, 112,924 feet equals y. If you convert that over to miles, you will get 21.3 miles. Okay, pretty simple. And then lastly, find the altitude of the plane when the pilot starts his descent. Well, the altitude, guys, the altitude is where the plane is right now. Here it is. The altitude is right here, this line right here. Well, that's really easy. We'll call that z, okay? Well, look, here's your angle. Here's your hypotenuse. Here's z. So we have sine. Sine of 18.8 equals opposite over hypotenuse. 119,289. Multiply both sides by 119,289, and you will get z equals, and I did not convert this over to miles, but it's 38,442.8 feet. That's the altitude. So it was a long problem, but I wouldn't say it was that difficult to figure out, okay? Not too bad. All right, moving on to number 47. Okay, here we go, number 47. Now I've worked all these out ahead. I'm going to look at my notes real quick here. Okay, now what they want us to do is they want you to find the distance from the boat to the shoreline. Okay, so it doesn't matter if the boat's here, the distance is still straight down, okay? And it doesn't matter if you're talking about the boat here, after it's moved, it's still straight down, okay? So there we go. That's what we're looking for, the distance from the boat straight down to the shoreline. Okay, find the distance from the boat to the shoreline. So now let's go ahead and write some things down here. See what they give us. First of all, what I'm looking at here is I can put a distance from here to here. Here's where the ship started right here, and here's where the ship ended right here. Okay, now it says the ship is traveling 10 miles an hour, and it says he travels for 15 minutes. Okay, so in 1 hour the boat goes 10 minutes. So in 15 minutes, that's 1/4 of a mile, or 1/4 of 10 miles. The ship will go 2.5 miles. So now we know the distance from here, where the ship started, to here. Okay, now I'm kind of looking here. What can I do? And I'm thinking, I might be able to find the length of this dotted line right here, hopefully. And so I'm going to go ahead and draw this line right here. Now, that might help me be able to find this height going down. Now, here's what I realized. Look carefully, students. Please watch this. From here to here is a 90-degree angle. Got it? So if this much here is 70, then this little angle right here has to be 20 degrees. Got it? Now, look. This angle from here to here is a right angle. And then from here to here is 63 more. So the whole angle going all the way across from here all the way across the entire triangle is going to be 153. So here's what I have, students. I have a triangle that looks like this. Okay, well, that's not a very good triangle, but you get the point. And this right here is 2.5. In fact, I've never seen a worse triangle in my life, to be honest. So, and that really didn't help a whole lot, did it? Here we go. There we go. There's the triangle that we have. Okay, now watch this. This is 2.5. This is 20 degrees. This is 153 degrees. So this is 153 plus 20 is 173. This little angle down here must be 7 degrees. And I'm going to try to find this length right here. We'll call it x. Now, I'm not sure if that will help, but it's a good start, okay? So, here we go. Now, I have a pair. 7 degrees is across from 2.5. So 2.5 sine of 7 degrees equals x across from 153. So x over 153. Now cross multiply and divide and you'll get x equals, let's see, sine of 153. So you will get 2.5 sine of 153 all over sine of 7. Okay? And if you type that into your calculator correctly, you will come up with 9.3. So I know this length right here is 9.3. And now, guys, I'm really home free. I'm done. Look at this. I mean, all the hard stuff's done. This is really pretty simple now. I have a right triangle. Drop this straight down right here. Come straight across over to this point right here. And now come straight down here. And I've got a right triangle. And remember what I'm trying to find is a distance from the ship down to the shoreline. We'll call this y. There it is. I got it. I've got a right triangle. I've got an angle right here, 70 degrees. I've got this here as y. This is my hypotenuse, so I'm good. I've got adjacent and hypotenuse, so cosine of 70 equals adjacent over hypotenuse. Multiply both sides by 9.3, and you will get 3.2 for the distance. That's miles, 3.2 miles. Okay, so 3.2 is the distance from here down to here. Okay, one more problem, we're done. Okay, one more. This is a tough one. This is a really tough one. So please take some really good notes, okay? Here we go. The angles of elevation are this theta and this angle right here. So here and here. Got it? Now, they want us to write an equation giving the distance d in terms of these two angles. Now, let me tell you what that means. If you see something like this, 2a plus b, I'm just making this up. This equation here would be called y in terms of a and b. Y in terms of a and b, because what it means is is what y equals is 2a plus b. So you've written y in terms of a and b. Got it? Now, having said that, watch this carefully. I want to write d in terms of these two angles. So my final answer should have d all by itself, then an equal sign, and I'll have some numbers over here, but also I'll have these two angles. This is really difficult, so really pay attention, okay? Now, let's think about this for a second, okay? It's not going to be easy to see, but watch this. Okay, angle B right here, as this airplane moves, and this whole line here moves with it, and this line here will go from here to, that's not going to work, but as that line slides over with the airplane, theta will get bigger, it'll move. But you know what won't, do you know what won't change? Is the fact that, now watch this, no matter what, this angle right here, B, and this angle right here are always going to equal 180 no matter what, always. So as this line here moves over to here, this angle here gets bigger and B gets smaller, but they still equal 180. Okay, now why is that important? Okay, well, watch this carefully. I'm going to show you why it's important. I can find what B equals, okay? Here's what B equals. This angle right here, I'm calling it B, I probably shouldn't, but this angle right here is going to be called this. It's going to be called this angle here minus 180, because remember, if I add those two angles together, what do they always equal? Now bring this over and make it negative, and B equals 180 minus the unknown angle. So this angle right here, I'm going to call it angle B, is always going to be called what? 180 minus this angle. Got it? Now, next, I can actually find this angle right here. Now watch carefully how I do this, okay? Remember, if I have two angles here, I add them together and I subtract from 180. In other words, watch carefully. If this, pretend this angle here was 50, and pretend this angle here was 100, I would add those two together and get 150, and then subtract from 180 and get 30, okay? We're going to do the same thing, only we're going to use variables instead of numbers, okay? So watch. We're going to add these two angles together, so I have theta plus this angle here. Now after I add this angle plus this angle, I then subtract them from 180. Okay, so I have 180 minus theta minus 180 plus this angle here. Now your 180s cancel, and you're left with negative theta plus your other unknown angle. Now I'm gonna change their order. I'm gonna put this angle first because it's positive, and then minus theta. Okay, so this angle right here is called this right here. Pretty cool, huh? So now we have a name for every angle, and now we're really ready to go ahead. And let me go ahead and do this. I think this would be a big help if I could do this real quick. Not really. Try it one more time. Well, it's close enough. So now I can put a 2 right here. Okay, now here's what they want. See this line right here? That's my D, so I'm going to call this D right here. Now here's what they want. This is called theta right here. No, we're almost done. Look at this, students. They want us to write an equation given the distance d. We can do this. Look, we have pairs all over the place. Law of sines. This side here, d, is across from theta. So we have d over sine of theta equals, I've got a 2 right here. Look at that. So 2 over the sine of, and this other angle right here. Now cross multiply. So d times sine of this whole angle right here. And now divide both sides by this, and we're done. D equals 2 sine theta over our denominator right here. Look at that. We did it, guys. We have distance in terms of theta and this other angle here. Okay? So we did it. We're done. That's all they wanted. They just wanted you to get d by itself and have a formula. And why is this helpful? Because, guys, look. At any time now, you can type in an angle. You could put an angle in here, here, an angle for theta, an angle for this unknown angle here, and quickly use the calculator and know the height of the airplane. Okay? It's a very, very cool formula or function. Okay? All right. I hope this homework video has been a help to you. If you have any questions, don't hesitate to call or email.